morning, everyone. I hope I am audible to all of you. In my previous mic check, I think Tashani confirmed, but just in case any one of you cannot hear me if I'm not clear enough, please notify Tashani so that maybe I can make some adjustments to be clear as possible. Right. So as Tashani introduced, yes, my name is Umar Firdausi, and I work as a quality engineering lead at Pearson Lanka. Just like some of you guys, I started my career in quality engineering back in 2011 with Producer Corporation. And in 2013, I joined Pearson Lanka as a QA engineer. Hopefully, at the end of this presentation, let's see, maybe most of you might start as QA engineers, being positive. And here I am today, a quality engineering lead. So I'd like to keep the introduction about me as brief as possible, but if you want to find out more about me, you're welcome to stalk my LinkedIn profile. So as Dashani also requested, I'd like to see as much as possible if people can turn on their cameras. That way we can make this a lot more interactive. I want to have this as a conversation rather than a lecture. So if you can, please do turn on your cameras. But before I get started, I'd like to know a little bit about you. So all of you who in this meeting, if you can just tell me your name and the program you follow, and a little bit of experience if you have, like knowledge with what Kiwi is, what you've heard, what you work with. Just could be even a one-liner. If you can share that, that would be really great. So I'll take about 5 to 10 minutes and give you guys a chance. So Tashani, whatever order you want to run these names, you can. I'd like to see if people can actually speak up a little bit, tell their names and the program they follow, and if they have any experience with QA, maybe not working essentially, but theoretically at least. Just maybe like a quick round robin to, as an icebreaker, so that we get to know each other.
Let's give a chance for the volunteers who would like to introduce themselves in first.
Hello, good morning, sir. I'm Priyanka Shan. I'm following information system degree, and I have worked with web development the past years.
Thank you, Priyanka. Any other volunteers?
Good morning, sir. I'm Tejan Lakshan, second year student of Department of CAS, and in quality assurance, there is not many theoretical and there is not a lot of any theoretical and practical knowledge about the quality assurance. Only academic thing what we learn in the during the lectures, and because so waiting for more getting some knowledge from you. Thank you.
Sure. Yeah, thanks, Tejan. I'll do my best to give as much as possible insight within this short period of hours we have. Okay, any more volunteers? I mean, you don't have to worry. You can speak up if you're comfortable speaking in, English or Sinhala. That's fine. Then I just want to, get comfortable with you guys so that we can build a conversation. So there's no harm in whatever the comfortable language that you want to introduce yourself. Totally fine with me. Okay. Right. I know it's morning, working from home, or for you guys studying from home is as much as challenging as it is for, I think, us working from home. So without further ado, I mean, I'll get started with my presentation. And end of each slide, I'll maybe take a minute or two to take questions you have regarding that slide itself. But suppose you have questions overall or probably from content I have not covered yet, let's just reserve that towards the end where we will have a full Q&A session so we can discuss that in detail. So please do keep those questions noted. Could be a common location for storing questions or either way. Right. My topic today is new landscapes in software quality engineering. As some of you did mention, there is not enough content that one could learn about quality engineering. And I agree, yes, it is not offered as a program per se, but in some programs it is offered as a module. But that is a very small amount of content, or it is very brief in comparison to what this industry has evolved to become. So I hope you can actually see my screen. And for today's lineup, I want to touch upon a few areas. So I'm not going to read through what I have in the lineup because I will be eventually covering these in the respective slides. So I'll quickly drill down and start off with the presentation. Right. So I want to start off with a question. How many of you know this person? Maybe you might have seen different kinds of pictures, but I hope I have the right picture too. But can someone tell me who this is? Anyone? Okay, let me.
Charles Babbage.
Yes, correct. This is Charles Babbage. So why is he significant in the IT industry or the evolution of computers? So I presume most of you may have heard of his difference engine. So Charles Babbage is known as the first person to produce a concept of a digital programmable computer. And he was credited with inventing the first mechanical computer. So, so Charles Babbage contributed with the hardware, but we're in the software industry. So I'm curious to find out, or we're curious to find out who is recognized as the first computer programmer. So anyone has seen this picture? Who this lady is? Does anyone know who this lady is? Okay, I know this is a very rare chance of knowing her. So her name is Augusta Ada Byron. So Augusta was a peer of Charles Babbage. Actually, she's someone who follows Charles Babbage afterwards when he had developed his difference engine, and she described an algorithm for the analytical engine, so which is one of Charles Babbage's inventions too, to compute Bernoulli numbers. So this is recognized as the first algorithm specifically tailored to be implemented in a computer. And due to that, she is cited as the first computer programmer. It's debatable. Some agree on this and some disagree around based on how things took place around the era. Some credit Charles Babbage as the first programmer because he, along with his difference and analytical engine, had also come up with programs, and some argue saying Augusta was only someone who helped improve that. Some arguments say that Augusta was someone who some arguments say that Augusta actually came up with the algorithm itself. Nevertheless, just to know a little bit of our history, that was the objective of this. So the beginning of software testing. So back in the, although we have a history where the computers begin in the 1800s, um, back in those days, programming looked a lot like this. Given the nature of the hardware and way things were programmed, it was something that looked a lot like this picture. So uh, although the computer was invented, or the first form of a computer was invented in the 1800s, where we could considerably accept the form of a computer and an early stage of programming, very close to today's context, or very close to saying that this was the foundation of today's programming, was identified in the early 1950s. There was only a very few computers around back then, and due to computers being bulky and very expensive in terms of hardware, it was not very popular among commercial usage. So back then, the programming didn't have anything significant to say as testing. This is early in the 1950s. But with the revolution, or the digital revolution taking place in 1980s, that changed the landscape of programming, and which you can see today, or which you can see in this slide, that programming in the early 1980s was evolved. That's when software started evolving as an industry and being commercially adopted. So this is when programmers realized that the code they developed was used beyond them, or was used now commercially, and the need to ensure bug-free code started to arise. And however, even back then, programmers were responsible for testing their own code. Testing back then and today is completely two different things. We'll talk about that when we come to the remaining slides. And today, programmers today, they don't look a lot like this, but today's programmers are having challenges with delivering software in a rapidly evolving industry. And most of the industries, or majority of industries, have adopted IT or software applications to make their businesses better. Therefore, there is a demand for fast delivery with high quality, or rather bug-free code. Now, this presents a fundamental challenge or a problem when you are expected to deliver software faster and with high quality. So back in the 1980s and the 1990s, the developers had time to test their own code. But now, with the high demand for new features and new software, developers have a problem with spending time for testing the software applications they have developed. So this is one of the fundamental problems that was converted to an opportunity, which we will discuss in this slide, and that will explain how the role of a software tester was born. So the rapidly increasing demand for software applications presented a new challenge to the existing model of software delivery. Developers were now asked to develop new code rather than test the code they have already developed, because the demand for software was such. So developers therefore were resisting in a certain way, and were not as motivated to test code that they have already developed. Something that we have seen over a period of time is also that developers, as much as they are not motivated, they are also somewhat incompetent in testing the code. Also, what industries realized back then was that as much as faster delivery with high quality was a challenge and had turned out to become an expectation, Meeting this expectation back then brought in a certain competitive advantage also, because there were many vendors with softwares, but quality wasn't something everyone was able to offer. So whoever who was able to offer quality software was able to achieve a competitive advantage. So hence the role of an independent software tester was introduced. Now I'm using a term here, if you can see, I'm saying software tester. So I'll pause there for a moment, and if you have any questions based on the content I've shared so far, uh, we can take a minute to discuss them here. So I'm going to pause for I'm going to mute for a minute and give you guys a chance to bring up any questions you have. If you don't, sorry, we'll go on with the remaining content. Okay, sounds like we're all good here. So let me go on to the next slide. Sorry. One thing that I wanted to mention is that alongside the introduction of a software tester role, as the industry grew, there are also other roles that came into play: business analysts, product managers, project managers, program managers, and so on. So that all adds on with the expansion and the and based on how the industry evolved. So software tester. So there is a difference from a software tester to a quality engineer. So quality engineer is the most recent term that we talk about, or quality engineering is now what we refer to as overall software testing experience. We don't use the software tester term much today in this industry, and eventually with time it will be replaced. But it's important to understand the difference between both of them, so that you would know when you step into the industry and when you plan to take up the role of a quality engineer, what would be expected out of you. Back in the days, this role is still available. This is still practiced in certain companies in Sri Lanka and globally. The role of the software tester is, so if you're familiar with the software development life cycle, there is a testing phase there. So the software tester would be primarily active during that particular phase, so which is the end of the development and implementation of the application. And the software tester would explore the application with the intention to see if it works correctly. However, we'll also be looking for bugs. And the software testers are focused on ensuring the quality of the product. Even today, this is a somewhat of a manual effort. There are areas where this can be automated, but primarily manual, because it takes a lot of experience and understanding of the domain, and especially exploratory testing to make this a lot more efficient and beneficial. So with a quality engineer, what's different? So as most of you may know, you've come across applications probably when you worked in organizations as interns, and also from the applications that you use. Today's applications are a lot sophisticated in terms of their architecture, in terms of infrastructure, and so on, and also based on the programming languages that they have been developed on. All of this together, this combination makes software applications very complex and sophisticated. So when something becomes sophisticated and complex, chances of something going wrong or chances of a bug being introduced is very high. So it's not enough to basically test the application at the end of development alone, because it can and it will definitely be very costly to fix a bug in today's development methodologies, especially with Agile, where we are rapidly delivering software and we can't afford to have a separate testing phase for an overall application piece that's developed and then report bugs, because that's going to be too costly. And also the level of testing we'll have to do today is very high to ensure that we have that we introduce less or zero bugs to our customers. And unlike a software tester, a quality engineer is focused on making creating a smoother customer experience. And again, significantly compared to a software tester, a quality engineer has to focus or will focus on the process. So this is the overall development lifecycle itself. So today, quality engineers are involved in planning, designing. Some work closely with developers and understand the code base. And based on the insight they gain from all of this, they tweak and come up with very efficient test cases, manual and automated, and actually then execute their test. So this way of testing, or this way of this practice is regarded as very efficient and has proven time to time that we catch bugs early before they end up in production and before they are observed from a customer. And because we are able to identify bugs early, and when I say bugs, I'm not only pointing out that bugs can come up in code. There could be bugs in the design. There could be bugs in requirements classification. So all of this can be eliminated soon as a quality engineer is involved early in the process. So like I mentioned, this is somewhat manual, but is trending and is vastly automated. So I think this is an important slide for you guys because you will be entering the industry anytime soon, within the next year or two, or for some of you maybe after 3 years, I guess. However, even with your intern experience, you might enter this industry soon. So it's important to understand what quality engineering today looks like. So many applications today have adopted different patterns, design patterns, microservices, serverless computing, and alongside most of these applications are hosted in the cloud infrastructure itself. So this is like a new landscape of software engineering itself, where we are now moving out of data centers, we're moving into the cloud. So that presents different kind of a challenge altogether. And because of this, development of much more complex application at a rapid phase is now actually in progress. And the fact that software is now taking a complex nature itself, like I explained in the previous slide, the availability of the new resources infrastructure has enabled complex software development. And because of the software being developed in a much more complex manner, the unthinkable can happen, which is something can go wrong. The chances of something going wrong is very high. And therefore, now companies, organizations are stressing the need of a strong quality engineering team or strong quality engineering practices in their overall development delivery process. So today's QAs have a challenge, and unlike before or unlike 5 to 10 years ago, today's QAs are expected to understand application architecture. So you need to understand your application and the architecture it has been built on top of. And we are expecting to be able to test at different tiers, unlike before where testers, or to a certain extent even quality engineers, were testing an end-to-end flow in a given application. We now want people to be able to test at different tiers. So the presentation, basically the UI, applications or the services, independently, and also databases. So this way we can isolate if there is a bug, and we can know for sure where it is coming from, unlike an end-to-end test, which will also give you bugs if at all. However, it will be very costly to troubleshoot and isolate where this bug is actually occurring from. And so I think maybe you already know about functional testing. So I'm not going to talk too much about it, but I want to stress something that's an emerging trend. Rather than a trend, this is a growing demand. This is an area where the demand is now growing. As much as building complex application is good, I'm pretty sure none of us would like to still work on old UIs, old interfaces, and we would not want to use applications that may not be compatible with our browsers and our devices. So hence the focus towards non-functional aspects of the application is also emerging. And therefore faster internet and powerful hardware that's available demands that applications deployed and running respond faster. So performance, in one word, if I put that, its performance of an application is now under the spotlight more than ever before. And organizations are now adopting performance testing practices as part of their delivery cycles. So before an application is released, as much as you would do functional testing, you would also want to run a performance test to ensure that your application responds within an agreed SLA or within a certain baseline. So it's more like you have a very sophisticated or very like a complex application with one of the best UIs, but if it takes about 5 seconds, for an example, for a home page to load, or 5 to 6 seconds, today that's too slow, because internet is a lot faster and people have therefore become less patient. And with the availability of devices and applications now being accessed to mobile devices and going into smart devices, actually, we are expected to see if applications are compatible across devices, as we did before when we used to check them with browsers and platforms. But today it's about also being able to support different devices, different operating systems that run in those devices, and different versions of the mobile browsers. So that compatibility is a new landscape it was not something that was recently introduced, but these are all there as theories before, but were not adopted based on the priorities at that time. But now today, there's a lot of focus towards compatibility and performance. Also, no matter if your application responds within, say, 3 seconds, if it's a UI, and if it's working across a device, but if it's not very user-friendly, again, chances of it being rejected by a customer is very high. And maybe some of you might have seen this, the amount of attention that accessibility is getting today. And if your application is accessibility compliant, chances of it being recognized recognized by customers is also high, because that enables a certain market, a certain set of individuals to also successfully use the application. So the key areas that I mentioned here: performance, compatibility, usability, and accessibility. So with the traditional quality engineering practices, most of the QAs were oriented towards functional testing and all aspects related to that. However, today, the industry is demanding for individuals who are equally competent with running a performance test, identifying potential areas that could impact performance when an application is released, making sure that applications are compatible across devices and browsers, and also making sure that applications are user-friendly and have a higher usability index, and also that they are accessible or accessibility compliant. So this is also areas that QAs now need to expand their knowledge. Expand into. You need to be able to take these roles up as well. So we'll talk about how different organizations adopt each of these practices and the different expectations probably towards the end of this slide. But for now, I just want to touch base on areas that are being which are coming into light where quality engineers need to also be competent with. Okay, sorry about this. Yeah, so if you're planning to become a quality engineer, the skills that you need to have and the tools that you need to be familiar with. So primarily, something that differentiates between a quality engineer and a software engineer is primarily the skill set. Tools and frameworks can be learned even by a developer. However, a skill may be not as easy as tools or frameworks. Attention to detail. So it is easier to misunderstand a requirement. Hence, attention to detail is important there so that we understand clearly what the customer's requirement is, because that's basically what we will be evaluating our tests against too. So attention to detail from a quality engineer is very important because the start of the life cycle itself is the requirement. So if you mess up with the requirement, at the end, you may have something developed very well, but then that doesn't meet the requirement. So if you know that something was wrong at the requirement level itself, or if you understood the requirement right, you will be able to identify an issue, a bug, or something that was not implemented right, even at a design phase. The next thing is good analytical and critical thinking. So I've actually put something here. I've put something called spectrum thinking. Does anyone know what spectrum thinking is? Anyone? So you want to take a shot at it? It's still fine. You don't have to give the exact right answer, but at least an attempt would be nice. Just to, that will give me also some insight that you guys are focused or engaged in this. I can see the name, so I can call out names. Or at least if someone can tell me what critical thinking might be.
So, this is just a guess. Is in a spectrum thinking? Is it trying to understand the patterns of the problem? Is it?
Well, not exactly, but it may involve trying to understand the patterns. So spectrum thinking is more or less understanding the in-between. So if if I tell you maybe a very hypothetical scenario, if you have come across color lights. So there are three colors in the color lights, right? So red, amber, and green. So red, we know for sure that we need to stop. Yellow, is get ready to either stop or go, and green is clearly go. So there is a pattern in how this color lights work. So spectrum thinking is more to do with, rather than testing the obvious, trying to test the in-betweens. More or less, like if I ask you to test a color light, you would of course see first if the red light would work, and then you would see if the green light works separately, and then you would see if the amber works in between. But when you put spectrum thinking in place, you would want to see if is there a possibility if the green and the red light burning together at the same time, because it's important to understand if that happens, what kind of a behavior are the customers or the passengers in the road expected to do. And we all know that that's not an accepted pattern, but if due to some fault, if that happens, people are going to get confused at the same time. Like if the red light and the green light works, the road, some of the passengers, some of the drivers are going to go, some of them may stay. So that may cause accidents. So it's important to mitigate that scenario. So how you can mitigate that is by thinking a little out of the box or thinking in between, rather than not going with what's obvious, but you try something which is not obvious. So that's simple examples for spectrum thinking. So when you think in this pattern, one way it will help improve your thinking, and that's also in a way regarded as critical thinking. So the opposite of this is binary thinking, where you only test the obvious factors. So when it comes to QA, if you want to succeed as or be regarded as a very efficient quality engineer, you need to have thinking, critical thinking as an improved skill set, because that's when you will see gaps in requirements, you will see areas that could be further tested or areas that have not been tested in application, and you will be able to come up with a lot more efficient test cases. Right. So the third one. So the third one is an important skill to have, but I think maybe it's not exposed, or maybe it's not explained as to why this is important or how it can be important. See, when in today's context, in teams that we work with, we have different individuals. You have developers, you have a scrum master, you will have your own team, QA engineers. You will be working with business analysts. You may work with a product manager or a business analyst, depending on the organization again. You may have application engineers. So a variety of people are involved in the deliveries, in planning, designing, to implementing applications. So chances of conflicts, misunderstandings is very high. Therefore, I mean, even within the same family, among siblings, when there is chances of conflict, I think that without an argument, we should be able to accept that the chances of conflicts with different individuals coming from different backgrounds and playing different roles in teams is very high. So a QA should be able to communicate very well. So communication or clear communication can help mitigate or avoid unnecessary conflict. That being said, I'm not saying conflict in an organizational context is bad. It's good. It is a healthy practice as long as it's done right and not taken personally. So if you are able to communicate between different stakeholders, that is across your team and with the management of your team, clearly, for an example, if you want to communicate a bug, say you were able to come up with some efficient test cases and you now identified a bug. So this is a typical scenario in or a challenge that we have on a daily activity in our day-to-day activities as key individuals, is that convincing developers that this is a bug. So after a bug has been identified, now there is only one way you can convey that this is a bug, is basically how you communicate this. So good communication skills is important. Communication itself is a different topic, so I'm not going to go into it because that will deviate completely. However, if you have the opportunity to learn, if there is presentations on communication skills improvement, please do get involved because it is very important. And you may be technical. This is actually an understanding in the industry itself. Regardless of how technical you may be really good with programming, you may be really good with your tools, but if you are a poor communicator, chances of you being hired for either of the role you apply, I mean, even if it's not QA, if it's development, it could be project management, it could be business analysis, chances of them recruiting you is relatively low because in today's landscape, organizations are global or have at least global clients. So they want people who can still communicate well, because organizations may spend some time with giving you the required training for extra skills or tools which to do, which can be used to do with your job. But chances of them spending time and trainings on communication is very less. So that is something you will have to bring to the table when you come into an interview. So make sure you improve your communication. One way, if you really want to try, you can, some of you may have heard of Toastmasters. So that is also a good platform if you have a chance to get on board, do a little bit of table topics or, talk on a few topics and make sure you improve your communication. So I wanted to stress on that because sadly, even in our organization, when we interview a lot of individuals, they have really good technical skills, but they're very, very poor communicators. So unfortunately, we are not able to proceed with them because communication is very important to us and is very important to the industry. The next, interpersonal skills. So you're working with a team, so the chances of conflicts coming in is very high. So it's important to have a malleable attitude, be friendly and be flexible, and bear with your team members, put up with each of them. Each individual is different, so we'll have to be very diplomatic with how we handle and work with them. So it's important to have good interpersonal skills, being able to work with individuals and therefore with the team. Problem solving skills. This again is kind of connected with your critical thinking, and so problem solving, although we mention this as a skill, the problem solving skill may come to you at different levels in engineering, quality engineering, probably when you take roles of management or lead. And the last but not the least, ethics driven. So many organizations put QA under pressure because of delivery timelines. If you have worked or you may have heard of this also, sometimes QA has a lot of challenges in completing testing within a certain timeline, because sometimes there are delays in deliveries coming in, but the timelines from the customers do not change. Therefore, you have to crunch. And this is a situation where you go through a lot of pressure. And when you have a lot of pressure, under a lot of pressure, chances of you giving up your moral values is very high. Think of an exam that you're preparing for. I mean, it could be one of your semester exams. Let's say you were free and enjoying yourself for a couple of months, and then your lecturer gives you a coursework or an assignment, and maybe it's due in a couple of weeks, but then if you're a procrastinator, you realize, okay, wait for some time, and then the day before the coursework, you're cramping, and you realize that you cannot complete this with the exact quality that you have to give, or with the right set of answers. So you make up your mind and you give up the values, and you'll be like, it's just a matter of getting it completed. That's what's important right now. So this is something that individuals go through when they are under severe pressure. And I don't want to scare you up. When I say severe pressure, it's not a unrealistic level of pressure, but the normal pressure that is there in organizations. Sometimes people tend to compromise on quality. So regardless of the crunch you have, it's important to make sure that you stick by your ethics, is to ensure that you deliver is that you ensure quality in the applications you test. So never give up that, because that was the first and the primary reason you hired for an organization. So nevertheless, if times could get stressful, but there's always ways to mitigate that. And of course, that's where your communication skills come in handy, is that you let the stakeholders know ahead of time the risks of the chances of delays in delivery, and that you will not compromise in quality therefore. So along with the skills, there are some tools and frameworks uh, that are in currently trending. So there is a few that I listed here that are among those that are popular. But of course, there is more than this. There's a lot of tools and frameworks uh, than what I have listed here. But I just listed a few that are popular, and some of the tools that most of the organizations, when they look for individuals, they see if individuals are familiar with this tool. So being familiar with these tools will give you an advantage when you apply for a QA engineer job. So more than theory, try to get some hands-on experience. So if you are going to be involved in UI testing, UFT, so UFT is actually not a free tool. It's a tool from HP, Unified Functional Tester, which was previously QTP. And then Selenium. Selenium is a framework. Appium is also a Selenium-based framework, but more to do with mobile testing. Cucumber is a BDD framework, but Cucumber can be also used for API testing in a certain way. So when it comes to API testing, API RE and Postman, these are two clients that people use to test at a very minimum number of test cases. It's not a very popular automation framework, but the one that's very popular as an automation framework itself is API testing is rest assured. And then I listed two more tools, which is performance testing. Two more areas, two more dimensions: performance testing and compatibility testing. So performance testing, people are expected to know JMeter or load runner. I mean, it would be an advantage if you know these tools. And compatibility testing. As we have a lot of devices now coming into play, and applications need to be compatible with these devices, it's not practical to purchase all of these devices for organizations and to test, because it's too costly. So organizations go into platforms, shifting to platforms that provide this simulations. So two of the popular testing platforms that provide different device compatibility simulations is Source Labs and Browser Stack. So if you can be familiar with this, chances of you being hired at a reputed company is very high, because these are what we or the organization is now looking for. Of course, don't stop there. Don't stop there. I also want to tell you what it may look like in the future. So college engineering now is getting embedded closely with software development. I mean, you have to work hand in hand. It's not focused at one phase, but it's spanned across the entire development life cycle. So you need to be familiar with engineering practices. You need to be able to understand design patterns. And therefore, it is now transforming into a lot more of a technical role. So if you want to start off, and if you are comfortable being a manual tester alone is not going to be enough. If you want to pursue quality engineering as a career, you will have to become a lot more technical. And that is what the future is going to look like, and it will be a lot more eventually. So in my previous slide, I spoke about various tools and frameworks that are available in the industry today. However, with the amount of resources available, infrastructure available, for an example, stereotypes are being broken when it comes to developing an application. Where, say, before, if you would always stick by an RDBMS, now you would want to go into a NoSQL database in the application. Like the development team might decide they're not going into RDBMS, they're going with the NoSQL database. So if your automation framework that you purchased, or which you have picked up from the industry, as an industry-wide framework only supports RDBMS, you're going to have a challenge on how to test a NoSQL database. So QEs now need to be able to evolve to a point, step up to a point where they can actually build custom automation frameworks. So this is something where this is a gray area, or like a blue ocean area where it's not heavily dominated yet. A lot of people still need a lot more technical skills before they can even get to this point, but this is something we are looking for and will be in high demand in future. There are a lot of frameworks still available, but the capability to build something from the scratch whenever and wherever required is also now going to be part of an expectation from quality engineering itself. So that is another testimony to tell you guys that how technical this role has now become from the previous tester that I spoke about. So you can see for yourself how this has evolved as a career and how it has now become a more technical oriented role. So something we also see when we interview individuals is when we ask them about their programming language competency. Sadly, it is at a very minimum state. Some people are good, some people, majority that we've seen are not very compatible or not very competent with the programming language. So this understanding programming languages, especially the ones that your application is being built with, will give you a lot of insight to areas that you can omit from testing, because there are fail-safe mechanisms now that are offered through the programming languages itself. So you need to be able to test this programming. I mean, you need to be able to trust these programming languages, and to do that, you have to understand the programming language well, and to a certain extent, at least I would say close to a developer. But however, this is with the objective that your end goal is to ensure quality of the application. So therefore, this knowledge is important to you. It will work in your benefit. So some organizations have now gone to the extent of expecting QAs to be able to write unit tests. So traditionally, or even as of today, in majority of the organizations or teams, unit tests are actually written by developers. But how this became an expectation is that even with a high number of unit test coverage that developers have, chances of bugs still being identified at an integration testing level or component testing level is still high. So that brings in a doubt of the efficiency of unit tests, and therefore, because QAs are have the mindset or the skill set of identifying potential areas with bugs, where bugs could occur, and flaws may have their flaws could happen. QAs are also now being expected to be able to write unit tests. Again, this is something that is still evolving. Like this is something which is coming into demand, and I would think the next year or two, this will be, you might see this coming up in a lot of job descriptions. And so this, alongside with medical requirements, that's where you may have heard of this new role being introduced called a full stack quality engineer, or full stack quality engineering. So this means we are expecting QAs to be equally competent as developers, but being equally competent as a developer will not essentially make you a developer, and that is because of your mindset. You strongly should bear the mindset of a quality engineer and the skills that I described before, because the knowledge you have here will be fuel for that engine. So you need to leverage that skill set you have alongside with the knowledge you get from this, with your exposure to the programming languages and understanding of design patterns will give you a very good advantage in playing your role a lot more efficiently. And within the next year or two, I think you should start seeing job descriptions coming from various organizations that they are looking for full stack quality engineers. So if you can complete and get a good amount of experience with on the areas that I explained before, uh, becoming one of the full stack quality engineers should not be a challenge to you. And also this role is to align with the trending DevOps culture. So I'll pause there a little bit. I want to actually ask a question from you guys. Are any of you familiar with the DevOps culture? Have you heard of DevOps? Do you know what DevOps is? Anyone? Any of you know what DevOps is? You may have seen. So this is probably not in your modules, but maybe through some webinars, or if you were in an organization as an intern, you may have heard of this term. No. Okay. So DevOps is about streamlining the entire delivery process, breaking many of the silos we've had before, where developers used to work in isolation in a different silo, and QAs would work separately, and then application engineers who would deploy the applications to an environment would work in isolation. So three of these individuals have three different understandings of the application being delivered. So DevOps is about breaking those barriers and getting these individuals to work together, communicate with each other, have the same understanding, and improve the delivery pipeline. So that's DevOps like in a nutshell, but DevOps is a lot more bigger than that, than what I explained. However, to fit into a DevOps culture, what we are looking for is our quality engineers to transform themselves into full stack quality engineers. Yeah. So I think this is also something you'll be interested in. Okay, let's say I start off as a quality engineer. What options do I have? How can I grow? Path, if I'm going as a career, if I am to pursue quality engineer, what growth path or pattern, opportunities do I have? So this is like what I have here is a mere demonstration, like just a very sample structure put together. Different organizations may treat this differently. So in majority of the cases, you start off as a manual tester, but now I would say you start off as an automation tester itself if you have the right skill set. And with your experience over a period of time, you can actually progress to become a test analyst. So if I am going to give a little bit of example from example from my own organization, if we start off as associate engineers, and then people can, after some years of experience, you get promoted as a quality engineer, and then eventually with your exposure and again, of course, experience, you can become a senior engineer. And from the same point of view, we give an option where you can pursue one of the two paths based on your skill set. If you are more management oriented, you can pursue the path of becoming a lead and then eventually a manager. But if you are more interested towards technology or being, tech savvy, you can pursue the path of a technical specialist and eventually become an architect. Eventually become an architect. So after you have either become an architect or a manager, you still have options to go into becoming directors within the organization, like senior managers or senior architects, and then eventually one day director or head of the organization or department. Yes. So any questions from what we've covered so far? I hope you guys can still hear me. Okay. So from a question that I heard at the beginning where someone mentioned, sorry, I don't recall the name right, where there was not enough content or learning resources if one would want to progress in as a quality engineer. So there are two places that I would recommend if you want to start learning about software quality engineering. So the foundation or the fundamental place that we would all refer to first is the ISTQB content. So ISTQB stands for International Software Testing Qualifications Board. So there's a series of exams that you can follow and get accredited. This is offered through SUSL Sri Lanka. So you can go visit the site STB and then you can actually see if you can do an exam and start learning through the ISTQB content, which will give you a good understanding of theories and various aspects of quality engineering. The next area that is currently in focus, where people are doing a lot of courses and gaining new skill set, especially in technical domains, is the Test Automation University. So this is actually a free platform where content is offered by industry individuals with good amount of experience. So it's very brief and it comes with up-to-date examples. So you can of course visit this site as well and you can start doing some courses and areas that I mentioned before also, like on those various dimensions or various landscapes. There are a lot of courses offered through this platform as well if you want to learn. So spend some time, I would say, in learning both of these, and especially if you are ISTQB CTFL certified, that is Certified Tester Foundation level. If you have completed this by the time you apply to an organization, chances are of you being hired is very high, because we understand that you have put some effort and you have learned the fundamentals of testing, and the amount of time that we or in organizations would have to spend in training you as QAs, because would be less. And we understand that programs that are offered as part of software engineering and do not contain enough information about quality engineering. So that's why organizations have some amount of buffer kept to train individuals they hire, but they need to have a minimum skill set. But if you have ISTQB in your CV included, you will have a very good chance of being hired. Yes, so that's the end of my presentation. I would like to take up any questions you may have. For sure, you will have a lot of questions about the industry, and maybe it could be particularly about QA itself. So we'll take some time here to discuss any questions. So Tashani, maybe I'll hand it over to you to mediate any questions that have been shared ahead, or it's being shared now even. Tashani, I think you're on mute.
Oh, sorry. Students, if you have any questions, you can raise them now.
Sir, am I audible?
Yes, I can hear you.
Sir, I want to know what are the differences between QA and QE, quality assurance and quality engineering.
Yeah, so quality assurance. Yeah, so quality assurance was more to do with the role where was primarily actually something a software tester was following up with. So where we ensure quality more focused towards the product itself. But quality engineering is about ensuring the process itself that we follow is of high quality, so that at the end of a delivery where we release a certain product, we have added quality included, because we follow a very because our process also included is of high quality. So engineering or quality in bringing in quality into that process. So if I give you an example, if you are equally competent with the developer in understanding design patterns, so there are various design patterns like I explained before, you can of course bring your knowledge also to the table and have maybe a debate about, say, a design that has been brought forward. You might be able to improve that design's quality based on your own knowledge of a design pattern itself. So that is one way you embed quality into that practice, or you embed quality into the design phase. So thereby, when you embed quality at different levels, it could be requirement, it could be design, it could be at each pieces, you able in process of delivery. I mean, that makes the process itself of high quality. So when the process is of high quality, the chances of bugs coming in without an argument is less. So clear distinction between QA and QE is about ensuring that the process also is of high quality when it comes to delivering software. Did that? I hope I clarified.
Yes, sir. Thank you.
Do we have any more questions?
Good morning, sir. Am I audible?
Hi, Malik. Yes, I can hear you.
Sir, you have mentioned that there is a UI testing process in the all testing process. Can you further more information about that process? What are the special features that UI testers test in the UI? That kind of things.
Okay. So when it comes to a UI, it's a different ball game there, because chances of a UI, so the UI itself is what your customer would first experience. You may have really well structured services, but a customer would never interact with the service directly. The place that a customer would directly interact, or the first point of contact to an application that a customer has, is the UI. So alongside with your functional tests, you would want to see if the UI first matches the UX designs presented by your UX engineers or UI designers that you have. Alongside with the functional testing that we do, I think I stressed on this dimensions. One of the key areas is compatibility. Many applications succeed in standard browsers, but what we've realized is when it comes to customers, most of the complaints coming in, or the incidents that keep coming in, is that applications are not compatible across devices, and the amount of complexities that JavaScript brings in to an application when it works with when you have to work with different browsers, especially with different versions, and also if you see vendors of these browsers keep releasing different versions of these browsers with different security features, especially like now that security is also on the spotlight for application. The complexities that a UI will have and that the UI will have to go through is actually big, and therefore the focus on ensuring that a UI is compatible across browsers, devices, and also now across different browser versions itself with different security settings, also falls on the shoulders of a quality engineer. Now, the challenge here is a lot of quality engineers work with traditional frameworks. I mean, frameworks that have been there for some time, for an example, like Selenium. But frameworks like this take time to evolve, and at the rapid state that developers or front-end developers especially release front-end components, it's not easy to maintain this automation suites efficiently. Therefore, there are focus. There is new frameworks coming in. You may have heard of Cypress. Cypress is also one of the trending automation frameworks, which is relatively easier to verify applications, especially I think if they're built on, if I'm not mistaken, either React or AngularJS. So compatibility in one side. Also, some of the some organizations, when we test usability, we make sure that the sizes of the buttons, the colors of the buttons, actually some of the QA engineers follow the source code of the application deployed, especially the UI code, to make sure that the buttons and have the right color patterns, have the right sizes, the height and width of the elements. So these are like granular level testing that is done to a UI to make sure that the UI is of high quality. Accessibility testing. The challenge with accessibility testing is that there's not much of open source tools available, to my knowledge. Most of the tools are proprietary. So you have to purchase the license. So many organizations sometimes have a centralized team that would perform accessibility testing for a large amount of applications developed by a number of teams. So you may have the chance to learn, or you may have sometimes a bit of a challenge in getting familiar with an accessibility tool. But I think there might be some free versions available too. But that is also important, because if your application in today's context is not compliant with accessibility, chances of it being adopted by a variety of customers is less. So that is also a focus. So the good thing about the trending QA today is that QAs are expected to define these landscapes, that this is important. We need to make sure that these areas are covered, especially when it comes to a UI. And you can, of course, take these arguments up to your product managers and get them prioritized to ensure that you cover the functional aspects as well as the non-functional aspects of the application. So I kind of gave a bit of a broad answer there. I hope I covered. I hope I covered what you were looking for.
So thank you.
Sure. Maybe we may have time for one more question, I guess.
Good morning, sir. I have a question about how the recruitment's going on in a Pearson.
Did you say recruitment?
Yes.
Okay. So with at Pearson, what we're looking for now is that we have now paved the new landscape for quality engineering, and I think the upcoming recruitments will be for people with good skill sets in terms of technical skills too. However, if you are a fresher, if you're starting fresh with industry, what we look for is primarily your skill set and ability and willingness to learn. If we see that you have the required skill set, some of those which I mentioned before in my presentation, alongside your familiarity with programming languages, of course, we all come from an IT background, but unfortunately, what we've seen with QA is that they don't really prioritize their knowledge in terms of technology. They do have the good skill set to test, but then again, when we test their technical skills, so much. So both together is what we will be eventually looking for. But primarily for your skills that we think a QA needs to have is what we look for from freshers who join. So and also if you are joining at a different level, say senior engineer, or if you're coming in as associate lead or lead, then expectations are different. Like that's a lot to do with experience. So eventually when you are in an organization and you have gained a certain amount of experience, you will be a different kind of an individual. I mean, shaped differently by being in the industry itself. But what I explained was this for freshers in the industry. What we look for.
Thank you, sir.